My name is Shackles. I'm here from New York City, and I do all sorts of stuff in the community. I work for a company, startup called OLO in New York. Basically, I'm just involved in the community, write articles. I have a book out, et cetera, et cetera. I run a user group around mobile.net in New York. So if you're anyone here from New York that I don't know. So if you know anyone in New York or you're in New York, definitely check out our group. We do all sorts of stuff. And my Twitter handle, my email address, a GitHub account that has all the stuff that you're going to see today. And I'll be around for the rest of the conference, obviously. So let's just dive right in. So if you've been to any testing talk before, you're probably thinking that this might end up being some big diatribe on trying to drive TDD down your throats or something. And naturally that lends itself to all sorts of other acronyms being thrown at you, just one after the other. You have to keep it simple and don't repeat yourself and so on. And I don't know about you, but by the end of a talk like that, I would be sleeping, even if I was the one giving it. And that's not really what I want to do here. So what I really want to do today is take a more practical, have a more practical conversation around testing. All those big letters on the previous slide, those all matter, those are all important, but they just they're part of the picture. And me sitting here lecturing you on solid and what's called principle and all that kind of stuff, that's just boring. So let's take a step back and talk a little bit about why writing tests is important. Out of curiosity, is anyone here into testing? It's a really divisive subject, I found, as I started writing a talk on the subject. Is anyone here doing any testing at all for mobile apps? Out of you with your hands up, how many of those, are you doing integration tests or unit tests or all UI testing? Okay. Okay. Cool, and so that was maybe half the group is doing testing. So hopefully I can convince the other half of you that it's worth looking into. So let's look into why. And the obvious one that you're going to get from talking about why you should do testing is, it helps you keep your system stable. It's not really that interesting of a bullet point to give, but it's still worth mentioning because, having a set of tests to fall back on, a nice test suite, it allows you to keep your system bug free, make sure you don't reintroduce something that you fixed in the past, and so on. It allows you to have a little bit more confidence as you're changing your system around that you don't have any regressions and you haven't broken anything that you're taking for granted. The bigger your applications get, the more stuff is in there, the harder it is to keep track of how the whole system is going to behave. So just having a nice suite of tests is a really, really nice and easy way to keep track of all of that stuff. And we're talking in the context of developing with C# here. So you have the benefits of a nice static compiled language. You find out a lot of stuff at compilation time, as opposed to if you're using a dynamic language where you just your app would crash right at runtime. But really, we all know that just because a project builds doesn't really make it correct and doesn't mean it works, and it doesn't mean that it's going to continue to work as you keep iterating on your app. So compilation is awesome, but it should really only be considered your first unit test, and you can just kind of take it from there. And the other big thing is that the tests that you're writing, you're all probably targeting at least one platform, probably 2 or 3, and the tests that you're writing, those can actually be run on all the different platforms that you want to target, and we'll talk about this a little more later. But you can take your exact tests, run them on iOS, run them on Android, run them on Windows Phone or WinRT or desktop.net. Anywhere you want your code to run, you can run these tests, and that's actually really huge. So a lot of times, we've all probably been bitten by the JIT problems that can happen on iOS. You can actually find out a lot of that stuff right at testing time just by running your unit test on the system. You don't have to wait for the app to load into a simulator, into an emulator, or whatever, and click through, get to that screen you're at, find out that it actually doesn't work, and then have to go all the way back through the process all over again. And the same applies to problems with the linker as well. And everyone in the room, I'm guessing, has been bitten by something being linked away at some point, and tests are actually a really useful way to just flag that right up front. So I'm guessing a lot of, at least half the room has probably said something like this before. I mean, it's the most common reaction I get from people when asking why they don't do tests. And a lot of people just say, well, I have to ship. You know, I don't have time to just sit here writing tests. I have an app to ship. And given that I'm up here at a podium talking about testing, it should be of no surprise that that's what my response would be. So hopefully I can convince at least a few of you that this has some merit. And I think it has some merit, especially in the case, I'm big into testing on the desktop. I'm a web developer in addition to mobile developer, and I do a lot of testing there as well. But it's a lot different in the mobile world. And I mean, if you saw Nat's keynote earlier today, he kind of set the stage and almost shared some bullet points with me. So hopefully, if he didn't convince you, I can get you the rest of the way. But once your app is out there and say like the iOS App Store, like it's out there, and there's no easy way to pull it. Bad reviews are going to start coming in. And this is an example that happened a few months ago where Amazon released an update to their Kindle app. They realized after it was published that anyone who installed the app, it would have their entire media library deleted. And the best that they could do to recall this app was change the description of the app in the store to say, please don't install this, pretty please. Bad things are going to happen, and then wait for Apple to approve the next version of the app that fixed the bug. And you don't want to be in the position of like relying on your users like opting in to fixing some bug that could have done really terrible things, and they might just not come back to your app. Like this isn't the web where you can just change the code. The next time they refresh the page, everything is rainbows and unicorns. And problems like this they're difficult to fix. They're expensive. They're going to cost you time, money, customers, and they're just things that you don't want to have to deal with. And especially in the world of mobile, the bar for quality in the apps that you're putting out has been seriously raised. As Nat was saying earlier, even enterprise apps, there's a much higher level of quality and expectation there. And you really want to do everything that you can to make sure that you're delivering to that quality and keeping your system functioning and stable and working as you put more and more versions out. And the other side of it is users will let you know when your app sucks. And they're probably more likely to let you know when it does something wrong than right. And those reviews are going to stick with you for a really long time, and future potential users are going to see that. That might send them running. So you definitely want to be really careful with the quality you put out there. So that's a whole bunch of negative and unhappy faces and blah blah blah. So there are other good. There's more benefits to testing than just avoiding the bad things. So I want to go through some of that now, so it doesn't sound like I'm just talking about gloom and doom up here. You will have the benefit in your code of just your code design is going to get a lot nicer. You're going to start decoupling things a bit more. You're going to be able to share a lot more of the code that you write across all these platforms. So in addition to sharing the tests, just the code itself is going to get a lot more decoupled, a lot more shareable. You can run it on iOS, Android, Windows Phone, Windows Store, ASP.NET, wherever you want to run your C# code. It's just going to go with you. So that's always a plus. And so it really just brings in all of those big capital letters from the first slide, but it's more of a consequence than something you have to think about right off the bat. The other big thing, and this is one thing that I personally really like about this approach, is just that it lets you optimize a lot of features in your applications completely independently of a platform. You don't have to spin up an emulator or a simulator and click through an app 10 screens deep just to test some core piece of functionality, even database calls or something like that. You can really just wrap the pieces that you want to test in tests, and then you end up with a nice suite of tests that you can fall back on in the future. But you can also just iterate and get your feature working independently of any kind of UI around it. And then when you get to the UI that you want to work on, you can really concentrate on that UI. And just just being able to concentrate on like one discrete task at a time, for me, helps me iterate a lot faster. And I'll show some examples later of how I've applied this to kind of bigger app examples, but for me, this really helps me just get things done a lot faster and not have to context switch between, oh, the Android UI, the iPhone UI, oh, the underlying database code. And you can really just tackle those things, independently and concentrate on them. And of course, green tests are good for you. They make you healthier, fitter, more productive, and so on. So it just makes you a better person. It's science. You can't beat science. So we've talked about the why you'd want to test. So I want to talk about what kind of tests are out there, what you can target, the different approaches you can take to actually writing tests. And if, as I'm going, anyone has any questions, feel free to just shout or throw something at me. I'm happy to answer. So, what to test? When talking about what you're going to test in your applications, it's a pretty controversial subject depending on who you talk to. And if you start reading blog posts on the subject, you'll start seeing, like heated debates over how much of your system you should test, how you should test, blah, blah, blah. The one thing that I just want to say about that is that 100% code coverage should never be your goal. And it's really just an arbitrary number. Like, the thing that you want to concentrate on is just, you write tests around the things that provide value, the things that are going to give you a nice backbone, a safety net to fall back on. And you don't need to worry about writing up front, 1,000 tests just because you need to have every little piece of your system covered by tests. And then you're just going to be wasting time and fitting, what anti-test people usually associate with this. And the other side of it is testing platform code, like platform-specific code, is actually pretty difficult to write tests around. We'll get into this a little bit more later, and this also ties into the whole decoupling bullet point from the last slide. The more you can decouple things from your platform, in addition to being able to share them, it also makes them a lot easier to mock out and test. So in the case of Android, you don't have to worry about the context that's going to be passed around, or the view, or any of the state that's going to be in the application at the time. You can just test things independently. Because if you're trying to test them within the scope of an application, you're going to have a hard time. And like I said, 100% code coverage is definitely not the goal and shouldn't be. And neither is having a giant suite of tests right off the bat. If you already have an application that's difficult to test, that's fine. If you're adding a new class, if you're adding a new feature, you can write tests around that. If you're changing something, you can write tests that verify the behavior, then change it, and then make sure that it still works after the fact. And you add one test there, 2 tests, 5, 10. Eventually, you'll end up with a nice testable part of your system. But it's going to happen a bit more organically, and you don't need to just dive right in and say, oh, well, I really want my system to be tested, so I need to go out and write 1,000 unit tests right now, otherwise, bad things are going to happen. If you want to and you have time, then that can be awesome, but, in all likelihood, you're going to be spinning your wheels for a while and not really concentrating on the problem. So start small, and eventually you'll end up with what you want. And if you're starting with a brand new application, it's obviously a lot easier because you can really test drive your stuff, and you can design your classes right off the bat to be really injectable and mockable and testable and all of that stuff. But the moral of the story is, you do what you can, and you do what is going to provide value for you and your system, both now and going forward. So you can, if you've ever, been to testing talks before, you've probably seen the pyramid of test types, and this one's going to be no different in that respect, so my apologies if it's all old hat. But if you think of it as a pyramid, the base of the pyramid are unit tests, and these are just really low-level, very targeted tests, very quick to run. And again, we'll dig into these layers in later slides, but the more you can push down in your system into the unit testing layer, the less friction there's going to be, the more benefit you're going to get out of the testing approaches that we're going to talk about. So sitting above that, you have integration tests. And these can be run in similar ways to unit tests, but they have the difference of not really being tests that happen in isolation, so they involve hitting a real database or hitting a real web server. They could be super useful for just making sure that your system actually can talk to the things that you expect it to talk to. And it's not necessarily an either or with integration tests and unit tests. You can just leverage the power of both. And as I was saying before, if you're taking the approach of wanting to start small and little by little build up tests in your system, integration tests can actually be a really easy place to start, just because you don't have to immediately be able to mock everything out. You can just start by hitting the real REST service that you're gonna hit, or hitting the real database that you're gonna hit, and then slowly you refactor things and so that they're mockable and testable. But integration tests can be a super powerful and pretty low overhead way of just getting tests into your system. And then finally at the top you have user interface and user experience testing. And we're not going to talk too much about that in this session, because it's really just a whole rabbit hole of its own. If you were in the keynote earlier, you know that Xamarin has some pretty sweet stuff planned for this layer of testing, so that's totally outside of my area. I think there's a talk on that tomorrow. So we're going to concentrate on the bottom two here, but the thinner you can keep this top layer, again, the more benefit you're going to get out of automated testing. And as I said, so the bottom 2/3 here can be totally automated, and for the top, there are some ways to automate it. Obviously, again, Xamarin has the stuff that they're doing. There are other vendors that also that have their own tools, but there's also going to be a lot of manual testing in this stage too, and there always should be. So it's going to be a bit of a mixed bag there, and we'll dig into that a little bit more. Any questions so far, or is this all super easy and I should keep moving? Sweet. So, unit integration tests. The key with these is that you want them to be automated and really low friction. You can run them after every time you compile code, or every time you check in, you can run them on your continuous integration servers. The point of unit tests and integration tests to a slightly lesser extent is that you should be able to just run them, and they take a couple seconds to run in the case of unit tests, and you'll immediately find out, you'll immediately get feedback on what you broke or didn't break, or in the state of your system. And the other thing that really goes a long way in kind of helping you get into this and keep it as part of your workflow is just to really leverage the tools that you're working in. So in the case of either Visual Studio or Xamarin Studio, whatever, and you can set up little code snippets that will just expand out to write a test. Like when I'm working, I just write, I write test tab, and I have the shell of a new unit test with little placeholders for all the things I want to do. So it's really only a couple keystrokes, and I'm in, all the boilerplate is done for writing a new test. And then if you learn the keystrokes for pulling up the test runner and running all your tests, it really just becomes part of your workflow. And the less you have to think about it, the easier it's going to be to keep this going and keep adding tests to your system and keeping that working. So in the case of what we're going to talk about today and the current state of supported test runners, and on the desktop there's, I can't even name all the test runners, test libraries there are for .NET. It's pretty much any letter followed by unit exists, and they all have their benefits. They all have their pros and cons. That's fine. Right now, as far as the C# stuff goes on mobile, NUnit Lite is pretty much the de facto. I'm hoping to be able to do some stuff to bring in some more libraries in the future if I ever have sufficient free time, which is always the tricky part. But for right now, NUnit Lite works, and it works reasonably well, and it's essentially just a subset of the full NUnit framework. But it's really going to have probably 80 or 90% of the standard assert calls that you're going to want to do. And what I actually end up doing in my desktop apps is I just install NUnit Lite through NuGet instead of the full NUnit, and then you know that the tests that you're writing are going to be fully portable across all the different platforms, which leads into the next bullet point. So you can run all of these different tests on all your different platforms and just know that your code is going to run. You're not going to have any weird JIT problems or linker problems. You can just rest assured that all of your code is going to just work. And to that point, it also lets you observe that difference between a simulator and a device. And that goes for both the linker problems and JIT problems, and also just performance testing. It really allows you, now that you have these small segments of very targeted tests, you can maybe see, oh well, this runs super fast on the desktop, but when I run this on a phone, this takes 10 seconds, this is going to be a problem. So it can really let you optimize based on what you need and observe how your code is performing on all these different platforms without having to do it all through the actual user interface of your app. So it's really a lot more powerful in that respect. So mocking, I enjoyed it. So if you've done any unit testing before, you're probably pretty familiar with the concept of mocking, and you can think of it as having an interface and plugging in some sort of test implementation of that interface for the pieces that you don't really want to care about. And it allows you to inject predictable behavior into other parts of the system so that you can really focus on the thing you're trying to unit test. In the case of doing this for mobile, the options are a lot more limited than they are on desktop. And that's really, again, because of JIT problems. So most desktop mocking libraries will actually just reflection.emit classes right at runtime, generate all that stuff for you, which is cool and super powerful, but you just can't run that on an iPhone. So you kind of have to resort to manual mocking. Or I don't think that's an official term, but that's what I call it anyway. So you just kind of build up your own mocks. It gets a little tedious, but it's not really that bad to do. And it got tedious to the point where a couple days ago, actually it was during, I think, the first training day, I mocked up a little T4 generator for doing just really, really basic mock generation off of interfaces. It's super basic, and if you go download it and it doesn't work, I won't be that surprised because I haven't done that much testing on it. But I hope to expand it a little bit more. Right now, it'll basically just let you scan for interfaces and inject setters and stuff for them. And the code will basically end up looking like this. And this is the approach that I take when I do it manually anyway. It just gets tedious to maintain, so the more I can generate myself, the better. But the approach I usually take is to just, if I have an interface iService and that has a string method foo, then I just have a property where I can inject the body of that function and then just call that. And it's really crude, it's not pretty by any means, but it gets the job done, and it's going to work across all the different devices, and that's the big thing that I usually go for when I'm doing these tests. So, how am I doing on time? Okay. So, manual testing. So, we've been talking all about automated testing and ways that you could just do everything automatically at the click of a button or a keystroke. But that's not to say that there's no reason for a QA department in your company, or for you to be testing your apps, or to have your users testing apps. There should always be a manual element of testing for your applications, no matter what. User feedback on your apps is absolutely critical. The thing that matters the most in the end is not that you can't just tell a user on the App Store who left you a 1-star review, but my 1,000 unit test passed. That's not really going to fly as a valid excuse. The thing that matters is absolutely as Stuart put it earlier, the app is king. You have to ship, you have to have a stable app. The test can help you get to stability, but the user experience matters a lot. So getting the app out to users and getting feedback on that is definitely critical. That allows you to do the user experience testing as opposed to the UI testing. And it allows the people doing the manual testing to really spend their time testing stuff that needs to be manual, and they don't need to be as worried about all of the little intricacies of the app, because if you have this big subset, you have this big set of tests that are verifying a lot of the behavior and a lot of the underlying things, then you can just let your testers go wild and do all the crazy stuff that you didn't think of and hit all the edge cases. And sometimes those things can work their way back down and become new unit tests and so on. But you can allow humans to do what humans do best, and that's screw things up. So, and everyone here has probably heard of TestFlight before. This isn't like a big revelation or some secret service that I know about and no one else does. But I wanted to mention it here just because it's super useful for this. They also just recently introduced Android support, which is way, way better than just emailing APK files around to people. So I definitely recommend checking it out if you haven't already. It's the only good way I've found to distribute on iOS, and now that they support Android as well. And as you can see in the screenshot, if you haven't seen it before, it's integrated right into Xamarin Studio. So you can just one-click deploy. It'll use the TestFlight API and just send your app straight up to TestFlight, notify your beta testers, and you don't really ever have to leave the IDE to do any of that. So it's pretty amazing. So one last slide. And was anyone here in Stuart's MVVM talk earlier today? Awesome. So you guys are familiar with MVVM Cross. That MVVM in general is a pretty good pattern I found for enabling a lot of code sharing and enabling a lot more testability in your apps. So the library I've been using is MVVM Cross, written by the guy in the red shirt over there. So if you don't like it, go yell at him. But I do. I like it. So, and I yell at him. So. But the thing I really like about it is that it allows me to share a whole other layer of my app that I could without a pattern like this. So, and the key thing here is that you're not sharing views between the different platforms. You're not really imposing any view limitations on iOS or Android just because you have the same view model underneath. For a lot of applications that you're going to build, the general behavior of an app is going to be pretty similar. You're going to have standard screens. You're going to have the behavior is going to be very consistent, and the commands that you're going to do are going to be very consistent. It's just how you expose that up to the UI that usually changes around a lot. So this allows you to share that behavior in addition to all the underlying things around it, and still put the view on top of it, but you could actually test drive the view model entirely. And I have some demos around that later too. And you also get some other niceties that you don't really get on the stock platforms, and one of which that I really like, of course being a big tester, is just having nice inversion of control support. So without a nice framework like this in place, the best you can really do for something like inversion of control is just to use an IOC container and do service location, which you can do, and there's good libraries out there like Func and TinyIOC, but you'll still have to do the container.get service and things like that. So you don't really get the injection. Your things are a little more tightly coupled than they would be with nice constructor injection or anything like that. But in the case of the stuff I've been building with MVVM Cross, what I've actually been able to do is just take all of my service dependencies in a view models constructor, which I can then write unit tests around and test all the behavior without ever needing to spin up an actual UI app. And again, I have demos for that stuff. And because you have all this behavior there, and MVVM also goes hand in hand with the whole concept of data binding, the views that you end up writing on top get even thinner, which leaves less room for you to make a mistake or for things to go wrong. So there are definitely a lot of benefits to taking this kind of approach. Any questions about any of this stuff at all? All right, I'm putting everyone to sleep. All right, so let's get out of slides, and I'll try to get through this stuff quickly. What I have 15 minutes left, I think. So let's jump into Xamarin Studio. So I put together a very, very contrived demo project just to kind of get the point across without having to do too much. So here there's this demo library project. There's a beer class. You'll notice that all my samples involve beer. That's me. Hi, my name's Greg. I'm a beer snob. So if you have, so there's just this iBeer search client. So imagine some dinky little app with a search box, and it's going to go hit a web service and search for a beer based on a query that the person entered. So all this is a task of IEnumerable beer that gets returned based on a query. There's no implementation here. I just have that interface. And then imagine you have this a service wrapper in your application around it. And basically all I'm doing in this service wrapper is, by the way, can everyone read the code? Is that okay? All right, cool. So it takes in a search client in the constructor, and then it has its own search function that also just maintains a little cache here, so that you can do some in-memory caching, so you don't have to keep going out. Like I said, it's a very contrived case, but it's a kind of pattern that I use a lot in my applications, just to make sure, if you're doing things that don't need to hit a database again, you don't hit the database, or you don't need to hit a really slow web service call if you already have the data cached from a previous one. So that's really all this search method is doing. It's just going in, it's saying, do a search. If we already have the results of this search, just return those. Otherwise, using the nice new async await stuff, just do a client.search, put that into the cache and return it. So really, really simple stuff here. And then if we take a look at the tests that I have, so search service tests. So there's a few very, very simple tests that I put in place. One, just you say you search for an empty string, returns no results, fine. Non-empty query returns the results from the client. And before I do that, so the thing, that library that I mentioned earlier during mocking, that's basically this nasty piece of T4 here that I wouldn't wish on anyone. It's only going to get worse, but I'll maintain that. And then what it generates is basically that type of mock that I showed earlier. So all that's doing is just generating, if you just ignore the very verbose namespaces there, it's just generating the very simple injectable mock. So in search service tests, I basically say, create a new mock search client, and the body just returns these results here. So that's the nice easy way of just having predictable results from this service that isn't the thing that's under test right now. And then when it comes back, I'm just asserting that the service actually returned the stuff that we had provided from the search client. And then there's a third test here that just says, well, if you search for the same thing twice, don't go out to the web service again and try to do the search, just return the one from the in-memory cache. So the way that I did that here is, after the first one is done, I changed the body of that call to throw an exception so that the test would end up failing if it actually did try and hit that client again. And then what you can do is, unit tests are built right into any IDE that you're going to use. So if I just come in here, and you can see that all the tests are green, the code is still stable, and everything is still good. And the only other thing I have in here is just an example of, maybe you have some XML parsing code in your system that is taking what's returned from the web service call and parsing it into, in this case, into a peer. Did that just, okay. So that's standard XML serialization stuff, nothing really interesting there. And then there's just one test around that, given some beer XML, can I parse that and get the beer out of it? So that's all that's doing. And then in the case of iOS, and again, I didn't want to live code based on how much time I had, but if you do, I can show it's file new project, and if you look under iOS, there's this iOS unit test project. So I'll show you what the runner for that looks like in a minute, but all I did for the stuff in this test folder, these are just file links to the test files that are in demo library.tests here. So those are completely shared, just like you would in a normal class library. If you wanted to share your code between iOS and Android and any other platform, you can do the same exact thing with your tests in this case. So these are the same tests, and then if I hit run here and pray to the demo gods, you can see that we have a nice little, no, not over there. Hopefully that comes back. I guess look this way in the meantime. Sorry, I don't know what that's doing. You can see that we have our tests here, and you could say run all, and in a fraction of a millisecond, you have the results of those tests, and those are running on right on the platform that you're targeting. And if you wanted to, let's see if the demo gods are really in my favor. I can do this. That is not working. Damn, so close to being flawless on this demo thing. There we go. Okay, I don't know what, let's do this. Okay, I don't know what the one on the left is. That's, demo fail. But it's not my app. So if you run them on here, this is actually my phone here. I can hit run everything, and you can see that this is actually a difference between running it in the simulator and running it on the device. There was actually a problem due to the linker where it linked away a constructor that I needed, and this is an easy way to filter that kind of stuff right up to the front and just find out that you have to fix your linker, or you have to change your preserve settings. And the one thing you need to do if you're gonna test linking through your test runner here, is you'll want to add an assembly preserve to the actual app that's doing the test running, just so that the things in that app don't get linked away, and then nothing will work. So it'll be a pretty useless test. But I mean, that's just a really simple example of how you can just write tests and target. You can do the same exact thing with Android. I mean, there's an Android version of this test runner. So you can just run it wherever you want, anywhere that NUnit runs, and you'll be good to go. Any questions about this stuff? It's quiet as group.
Can you show your snippet that you're talking about, the generator field? I just want to see what
yeah, totally.
when you run it.
Let's see, where's the test class? Here. Basically, I just do, test. Oh, do I not have it on this? I should have tested that before. This isn't my normal machine. Anyway, wow, okay. Way to call me on that one.
Sorry.
That sucks. But it works the same way that it would, like if you do prop tab or something like that. But I set it up to work with this template, so it's, I use like the method, like given when then type approach to naming, but you can set it up to work however you want, just like any other snippet. And that was embarrassing. So, any other questions about this demo? Yeah?
Are the test runners part of NUnit, or is that something else?
So the NUnit test runner is part of Xamarin Studio in this case.
Okay.
But really, like NUnit has its own test runner for the desktop, or Visual Studio has stuff built in.
So how about running tests for iOS and Android from Visual Studio?
And you have to deploy to the simulator or emulators or a device to actually run the tests. Because like I showed before, the results could be different based on what platform you're running. But this is a way you don't have to rewrite the code; you just run it.
But there are runners for Visual Studio for iOS and Android. Would be the same one?
Well, it's the same thing. I mean, the runner in this case is just an app. Like when you do file new unit test project, that's just this app right here. So this is just a standard iOS app. I mean, it has its own app delegate and all the same stuff. It just wires the boilerplate stuff up for you and just runs the tests that you give it. But there's nothing actually special about it. It's just an app.
Okay.
Yes.
What's the state? Is there an Android one that's similar to that iOS?
There is. It doesn't ship with Xamarin stuff. I mean, hopefully they start doing that. But Sebastian, the guy that made TouchUnit, also just has Android.unit. And I have a fork of it on my own that I'm trying to bring it up to a newer version of NUnit Lite. Is it over? No, okay. But it doesn't ship with it, but you can go to Sebastian's GitHub repository and get it. So while I still have a few minutes, I do want to show the MVVM approach that I took. Hopefully, thing. All right, I'm just sorry about that screen. I can't control that. But this is basically just a really hard to read Solution Explorer. Hopefully that's better. But this is basically just a little app that I made. You can think of it as it's the same beer search concept as before, where you can search for beers, you can search for breweries. It's hitting the Open Beer database, which is just kind of a free and open source beer search database. It's my Northwind. So I like to use that. I have a little library called Amarillo on my GitHub account that is a nice C# REST client for it. So if you ever want to use that as your Northwind, feel free to go take that or extend it. But basically, this is just a little app like that. So I have my view models. There's a pretty decent amount of code in here. It's super simple, but there's a lot of code. So if you just say, let's look at the view model for looking at the details of a beer. So you have some concepts like whether this beer is one of your favorites. It'll be a little star on the screen that you can select. You can toggle the favorite. You can select the brewery and go view the stuff. Go view what the brewery is. But you can see here that if you trigger the toggle favorite command, it calls this method, which is going to do a whole bunch of stuff. So using this as an example, let's take a look at the tests I was able to write around that. So if we look at view model tests and beer view model tests, I can write tests around the behavior of the view models here. So I could say things like, well, when the view model is loaded and the beer is marked as a favorite in the database, the view model knows that it's marked as a favorite. And getting more interesting, you could say, toggle favorite command, beer is favorite, and then the favorite is removed. And you can really test a lot of this stuff, completely independently of a UI. And I actually built this sample application totally from tests, just as a kind of a personal case study on whether TDD could work in this kind of scenario. It was a little more overboard than I'd probably go practically on anything I built, but it actually worked really, really well. And because I knew exactly what the behavior of this admittedly very, very simple app was, I was able to build the entire thing without ever touching Android or iOS until I wanted to build that layer. And that includes tests around, and just to zoom in a little, because I can't zoom in on that. But I even have tests around the SQLite databases. So in the case of the unit test, I just create a temporary database, because the SQLite database is just a file, and I just do my querying based on that. It gets created at the beginning of a test and thrown out at the end of a test. So you can even write a lot of tests around that, around your value converters. The service tests are usually pretty similar to the example I showed earlier, where you're testing things like caching and stuff like that. And you can see here, if I load up my unit test explorer, and hold on, let me make this a little bit bigger. And I'm just showing Visual Studio as an example here, just to show that this isn't specific to any one IDE. This is something that you could just do across the board, regardless of what platform you want to run in. And if I get really gutsy and hit play on all my unit tests, you can see my view model tests are a little heavy, so they are slow, slow-ish compared to manual testing or anything like that. But you can see that I have 52 tests here, and it's just lighting up. I know that my whole system's going to behave, and I can concentrate on the stuff I really want to target. Any questions about this stuff? Yeah.
When you're testing database, you like SQLite, like you just said, how do you do that? You just have a file already with the data in it, you generate it?
Sure. Let me show you how I'm doing that. It's not anything super elegant or anything like that. So if I look at my repository tests, you can see I have this class SQLite connection factory here. Stuart will be very mad at me for having an if-def there, but sometimes you just have to do what you got to do. But really, all this is it's creating just a temporary file. Where it puts that file is changing a little based on the platform it's running on, but that's the only real platform-specific thing here. So it's just creating a new database in a temporary file, and then there's a method to clean it up afterwards. And then if you look in my tests here, so setup in NUnit gets run right before every test runs, and teardown happens right after. So when the test starts up, I create a new temporary database, and then when the test finishes, I just clean up that database, so the file gets deleted, and you get a fresh data. The thing is that you want your unit tests, and this is more of an integration test, but you want them to be as predictable as possible. So that's why each test creating its own database and cleaning up after itself allows you to be a lot more predictable and not worry about all the stuff that's in it, or the previous test run's results affecting the next one's results and that kind of thing.
Well, what about the data? How do you, what do you do? You have the
Well,
data
if you wanted
already?
some stock data in there, you would have to put that in the setup if you wanted to use this approach. You could also, you could just have a real database that you're not setting up and tearing down with each one if you want to make it a little bit more brittle. But that would be, there's a lot of integration tests that do that too. So it really, again, it's just the right tool for what you need to accomplish. Anything else? Yeah.
You mentioned some IOC service locations.
Sure. So the one I usually reach for is called Tiny IOC. The reason I really like it, and I can show you that in here. So I have a third-party folder, and this app is actually using two libraries like this. So there's Tiny IOC, which is just a single file cross-platform IOC container, and then Tiny Messenger, which is just a single file cross-platform event aggregator, so publish, subscribe type stuff. And it works really well on pretty much every platform that I've tried using it on. There's other ones like Funk I've tried, which is really good. But like I said, Tiny IOC works really well just because it's one file that you put into your app, and there's no DLLs, no dependencies, it's just the one. Anything else? Yeah.
Any reason you prefer to use NUnit as opposed to Microsoft's test framework?
So
I guess it doesn't run on mobile, right?
Well, that's the thing. I mean, so you can use whatever's available on the platform. There's a lot of really cool testing libraries out there, but the reason I reach for NUnit now is because that's the only one that you can currently run. That's the only one where there's a runner right now on iOS and Android. So it really does work across the board. If you want to use MS tests, then you're going to be limited pretty much to Windows. Yeah.
You said there's no IOC containers that support automatic resolution.
Well, what do you mean?
Like when it automatically tweaking the bug roll whenever controller is instantiated automatically.
Oh, well, I mean, that really just boils down to what the platform allows for. I mean, like if you take something like ASP.NET MVC, where you can put in a controller factory that's what does the injection in that case. In something like Android and even iOS, it's more of a manual thing that you have to do. You don't really, there's no factory that you can inject into and say, oh, well, as it goes through this part of the pipeline, put all the dependencies in here. So you can stand up something else, like there's RoboJuice for stock Android that kind of wraps up a lot of that stuff. But there's nothing out of the box that can really do it. And is there another one? Or? Yeah.
Have you tried to integrate the iOS or Android runs of the test into a continuous integration environment?
I haven't, but it's definitely on my to-do list. And I'm pretty sure TouchUnit can be, because there's some settings in it for build servers and stuff. And it does, if I can pull this up really quick, and I realize that I'm pretty much out of time. But you can see there's actually a lot of information being put into the console here, so that would be parsable by something as well. Is there anything else, or is that good? All right, thanks everyone.